To show that any two vectors are perpendicular, it is enough to show that their dot product is 0. If theta is equal to 0 or theta is equal to pi, we know that sine any pi is 0. So since theta 0, theta pi means their cross product is 0, which indicates the two vectors are parallel to each other. Vector B cross vector A is always the negative of vector A cross vector B. That means the cross product is not commutative. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am, Vidhyaashram School of Excellence, Mysore. Here in this session, we are going to study about the projection of a vector as well as the vector product of the given vectors. Now here, let's see what is projection of a vector. So it is one of the application of your dot product. So projection of a vector on a line. Now, consider a line L here. So we have a vector A which is passing through the same initial point here. So we have a line. So the projection of a vector B is nothing but the vector P, you can clearly see here. So which is exactly to the perpendicular distance at right angle to the vector A. So if P is the unit vector along the line L, then the projection of vector of A is given by vector A dot P cap is equal to magnitude of A into cos theta. So which is nothing but it's a shadow on the line. It's a shadow of vector A on the line, and that is the unit vector among the line L. The formula for the projection vector can also be written in the form of A dot B divided by magnitude of B. If we consider projection A on vector B, so here I have taken an example of the line here. Now here we are considering vector B instead of line L. So if we want to find out the projection of vector A on vector B, then it is A dot B divided by magnitude of B. Similarly, if we want to find out the projection vector of B on A, it is A dot B divided by magnitude of A. So now clearly from this we can see a projection vector of vector A on vector B is given by vector A dot B cap. So B cap is nothing but B divided by its magnitude. So which can be written as A dot B by magnitude of B. Now let's take up some observations in this. If theta is equal to 0 degree, that means there is no inclination with the two vectors, then the projection of vector AB will be AB itself. So if you consider this as AB, projection of this vector on the line will be the same because there is no angle between them. So there is no theta between them. So obviously the projection of vector A should be vector A itself, which in terms we have written as vector AB is same as vector AB. Now if theta is equal to pi here, that means if the angle is 180 degree, then the projection vector of AB will be BA, which is the negative of vector AB. Now if suppose if theta is equal to pi by 2 or theta is equal to 3 pi by 2, that is, we know that for an odd multiples of pi by 2, the cos value is always 0. So therefore, when vector A is perpendicular to vector B, then angle between them will be equal to pi by 2 or some 3 pi by 2, any odd multiples of pi by 2, your cos theta value is completely 0. So there will be no projection of vector A on vector B or vector B on vector A. Hence, in terminals, we consider the projection of the vector as 0. Find the projection of the vector A 2i plus 3j plus 2k on the vector B I plus 2j plus k. So projection of vector A on vector B is given by A dot B divided by magnitude of B, which can also be written as vector A dot B cap. Projection of vector A on B. So A dot B, it's a product of the scalar components. 2 into 1, 2 plus 3 into 2, 6 plus 2 into 1, 1 whole divided by magnitude of this vector. So which is square root of 1 square plus 2 square plus 1 square. So which is equal to 9 divided by 4, 5, 6, which is root 6. 9 by root 6 units. Find the projection of the vector if vector A is on the vector B. So we need again vector A dot B cap, which is A dot B divided by magnitude of B. So A dot B means I into I component, 1 into 7, 7, 3 into minus 1, minus 3, 7 into 8, 56. Whole divided by magnitude of B is nothing but 7 square plus 1 square plus 8 square. So 7 minus 3 is 460 divided by root 114. Now next we'll take some few problems on the scalar product of the vectors. If vector A is equal to 5i minus j minus 3k and vector B is equal to I plus 3j minus 5k, then show that vector A plus B and vector A minus B are perpendicular. To show that any two vectors are perpendicular, it is enough to show that their dot product is 0. Since we use cos theta in the dot product and theta when it is equal to pi by 2, cos value is 0. So therefore, it is enough to show that their dot product of the vectors is equal to 0. Now let's find what is A plus B. So add these two vectors. So 5 plus 1, 6i, minus j plus 3j plus 2j, minus 3k minus 5k minus 8k. Next we'll consider vector A minus vector B. 5 minus 1, 4i, minus j minus 3 minus 4j, minus 3 plus 5 plus 2k. Now let us consider A plus B dot A minus B. So 6 fours are 24, minus 2 fours are 8, minus 8 twos are 16. 24 minus 8 is 16, 16 minus 16 is 0. So therefore, vector A plus B is perpendicular to vector A minus vector B. Now, we'll study about the second type of the product of the vector, which is the vector product. It is also called as the cross product between two vectors. So, we have two vectors, vector A and vector B, with an inclination of angle theta. So, the cross product of the vector is nothing but the vector which is perpendicular to both vector A as well as vector B. And the formula of vector A cross vector B is given by magnitude of A, magnitude of B, sine theta dot n cap, where n cap is the unit vector which is perpendicular to the plane containing this cross product, and theta is the angle between the vectors A and B, and clearly we use sine theta here. It should always lie between 0 to pi. Now, few of the observation in the cross product is your vector product is always a vector. So, when we take the cross product of any two vectors, it is again one more vector. The second thing is the magnitude of A cross B is given by magnitude of A, magnitude of B, sine theta, because since the formula contains n cap, and if you apply the magnitude for n cap, since n cap is the unit vector, its value will become 1. Therefore, the magnitude of A cross B is just A, B, sine theta. Next, if theta is the angle between them, then sine theta is given by A cross B divided by AB. AB represents the magnitude of vector A and magnitude of vector B. And if theta is equal to 0 or theta is equal to pi, we know that sine any pi is 0. So, since theta 0, theta pi means their cross product is 0, which indicates the two vectors are parallel to each other. Next, the cross product of the same vector as well as the cross product of the vector with its negative is equal to vector 0. That is, A cross A is equal to 0. But A dot A is given as vector A dot vector A is equal to magnitude of its square. But A cross A as well as A cross minus A will be equal to null vector. Next, If theta is equal to pi by 2, we know that the value of sine theta will be equal to 1. So therefore, the cross product is equal to just the product of their magnitudes. So for mutually perpendicular vectors I, j, k, so we have I cross I, j cross j and k cross k as 0, and I, j, k are in such a way that we consider this as I, j, k. If we take the cross product of these vector, then I cross j gives k, k cross I gives j, j cross k give I. So which is in the anti-clockwise direction. If we take this product in clockwise direction, then it will be in the negative form. That is, I cross k is minus j, k cross j is minus I, j cross I will be minus k. The last thing is, vector b cross vector a is always the negative of vector a cross vector b. That means the cross product is not commutative. Now let us study the component form of a vector product. The component form of a vector product is always indicated in the form of a determinant. So learning the determinant value of a square matrix has one of the applications in vectors also. So any two vectors in terms of cross product can be represented in the form of a determinant. So here we have considered two vectors, vector A, A1i, A2j, A3k, and vector B, B1i, B2j, B3k. So now the cross product of vector A and vector B is given by I, j, k, A1, A2, A3 in the second row, B1, B2, B3 in the third row. So we will get the cross product of A and B. So if we multiply this with the help of your binomial product, we'll get the expansion which is same as you expand in terms of determinants. So let us take few problems related to the vector product. The first one is, find magnitude of A cross B if A is equal to 2i plus j plus 3k and vector B is equal to 3i plus 5j minus 2k. So let's take first A cross B. So A cross B is given by I, j, k in the first row, components of vector A in the second row, 2, 1, 3, components of vector B in the third row, 3, 5, minus 2. So let us expand this. So we have I, 1 into minus 2, minus 5 3s are 15. Next we have minus j, because in the first row the sign convention is plus minus plus. So minus j, minus 4, minus 9, plus k, 10, minus 3. So we have here minus 79, minus 4, minus 9 is minus 13. So minus 13 into minus plus 13j. Next we have plus 7k. Now the magnitude of A cross B. So we have seen in the observation, that is the cross product is always one more vector. So that is why it is in the form of 17i plus 13j plus 7k. So now we need the magnitude of this vector. So that is the length of this vector. So it is always square root of minus 17 whole square plus 13 square plus 7 square. So that is equal to root of 507. Next question. Find lambda and mu if 2i plus 6j plus 27k cross I plus lambda j minus mu k is equal to null vector. So let us take the cross product of these two vectors. So I, j, k, 2, 6, 27, 1, lambda, mu, minus mu. So under the determinant, so this is equal to the null vector, which can be written as 0i plus 0j plus 0k. Now let's evaluate this. So I into 6 mu minus 6 mu minus 27 lambda minus j into, so minus 2 mu minus 27 plus k into 2 lambda minus 6. So this is equal to 0i plus 0j plus 0k. So clearly from this we can say two vectors are equal. So if two vectors are equal, then their scalar components are equal. So from this we can clearly see here 2 mu plus 27. So if we remove outside here, this becomes plus j. So here also it is plus j. So 2 mu plus 27 is equal to 0. And similarly, 2 lambda minus 6 is equal to 0 because k is equal to k. So from this we have mu is equal to minus 27 by 2 and lambda is equal to 6 by 2, which is equal to 3. So therefore, the value of mu is minus 27 by 2 and lambda is equal to 3. The next question is, given that A dot B is equal to 0, A cross B is equal to 0. So what can you conclude about the vectors, vector A and vector B? So now here clearly they have given A dot B is equal to 0. So if A dot B is equal to 0, this implies either vector A is equal to 0 or vector B is equal to 0. Because their scalar product is 0 means obviously any one of the components or the vector must be equal to 0. So that also implies vector A is perpendicular to vector B. That means the cross product of the vector, that means the dot product of the vector is 0 means the vectors are perpendicular to each other. Now here they have also given the cross product of the vector is equal to 0. So here also, if the cross product of the vectors are equal to 0, that means vector A is parallel to vector B. So it cannot happen simultaneously. That means if either vector A should be parallel to vector B or vector A should be perpendicular to vector B. Hence, since it cannot happen simultaneously, we can just conclude either vector A is equal to 0 or vector B is equal to 0. Next question. If the vectors A and B are such that magnitude of A is 3, magnitude of B is root 2 by 3, then A cross B is a unit vector. Find the angle between A and B. Since the cross product of the vector is given, we are finding the angle sine theta. So it is always modulus of A cross B, or we can say the magnitude of A cross B divided by magnitude of A, magnitude of B. Since they have given A cross B is a unit vector, then its magnitude is equal to 1. So here they have given it is 3 into root 2 by 3. So 3 get cancels. We have sine theta is equal to 1 by root 2 or theta is equal to sine inverse of 1 by root 2, which is pi by 4, that is 45 degree. So in today's session, we have discussed the projection on a vector as well as how to write or calculate the vector product between the two vectors. So we'll meet you in the next session. Until then, keep watching, keep learning and keep exploring. Thank you.